was how can you find the equation of a line from just coordinates without getting given the graph. What you'll see is that basically it uses a lot of the same skills in terms of finding a gradient and the intercept is pretty much the foundation for any straight line graph skills. We're going to try a question together. We're going to try 4, 8 and 10, 11. Now what you'll notice on this first slide, we're going to jump straight in, is that I've just given you the most common formula, which is this one here. So if you were to Google how do I do this, this is what it would come up. And this is it's a formula that looks really complicated, but it's actually not too bad. And I'm going to show you in the next bit how it actually works. But all I want you to think about is those 2 points, 4 and 8 and 10 and 11. If I was to draw a very quick sketch on a graph, okay, 4 and 8 would be not somewhere like this, 10, 11 would be somewhere like this. And normally we would have a line that goes through them, like something like this, and we would draw the little triangle underneath. So what we need to do is think, how can I, without drawing the graph, simulate that result? Now, when you think about that line, that triangle, the bit on the bottom tells you how much the numbers have changed on the x-axis. And the number on the side tells you how much it's gone up or down on the y-axis. So we know that the gradient, which is m, is equal to how much it's gone up and down, the rise, divided by how much it's gone to the right, which is the step. So when we look at these 2 points, you've started at 4 and you've gone to 10. So we can see that the change in the x-axis has gone up by 6. Oh, let's cut it off a bit at the bottom there. When we look at the y-axis, it started at 8, 4, 8, and then it goes to 10, 11. So it's changed by 3. So 6 and 3, we're recreating that triangle without drawing the sketch. And that's all that formula is doing. This one here is it's saying how much have you changed in the y-axis, how much have you changed in the x-axis, what does the little triangle look like? Now when it says the little 2 and the 1, okay, what that basically means is the first and the second. So the first coordinate was 4, 8, which means 4 is the first x and 8 is the first y, x1 and y1. Similarly, we look at the next one, 10, 11 is the second, so it's x2 and y2. So when we look at this bit here, it's saying, well, it went from 8 to 11. How much has it changed? Which was, if you remember, we had our 2 points. We've got our triangle. This bit here is obviously 11 minus 8, which was the 3. When we look at the 10 minus the 4, that's obviously the change in the x-axis, the bit on the bottom. 10 minus 4 is 6. So it's basically saying our triangle would look like this. There's our line. And then we can see that the gradient is a half. Okay, so it's just recreating the triangle, but instead of actually drawing it, we're working out what those values would be. But the question says find the equation, not just find the gradient. So how can we use that to find the gradient? Sorry, find the equation. Well, we know m is a half, and we know when we have a straight line, we always have y equals mx plus c. We now know that m is a half. So that means we can put that number in for m, which gives us y equals half x plus c. But that's still a y, an x and a c that we don't know. But we take the coordinate and say, well, any coordinate we know is in the value of x then y. So if we pick any coordinate that we know is on the line, we know the value of x and the value of y at the same time. So we can take the x is 4 and the y is 8 and we can put them into the equation. Y is 8 and x is 4. If you have this equation, 8 is half of 4 plus something, then it's a reasonably easy one to solve. Half of 4, of course, is 2. So you're saying 2 plus something is equal to 8. So this something must be 6. And now we've got the intercept. So once you've got the intercept and the gradient, and we know y is mx plus c, we know m, we know c, then we can simply start to put them in. We found the intercept was 6. We know the gradient is a half, because that's what we did at the beginning. So we can just put the m value in and the c, and we get y is half of x plus 6. And that is how you find an equation from two coordinates. It's the same idea as when you can see the line, except obviously you're not going to draw it. I mean, you could, but you're not going to. So first thing we did was we found the gradient. Always start with the gradient. Okay. You can either use that formula that I gave you by substituting in, which is this one here, or you can just think of it in terms of how much has x and y changed. It's gone up by 3, it's gone across by 6. Once you've got the gradient, you take the gradient and you put it in to the equation. And then you also put in a coordinate, because that gives you two values, an x and a y. Always use one whole coordinate, don't pick and mix and match from two. Once you put that in, you can solve the equation to get the value of c. It can be positive or negative, remember, so can the gradient. And then finally, you take the m, you take the c, and you put them in the equation. There it is. So hopefully that will help you with the last part of the activities you're doing, and let me know if you have any problems. Enjoy!